Hello guys, this is the beautiful problem, okay, of kinematics chapters. So we will try to solve these problems, okay guys. So in these problems, what is happening? There are three incidents, okay. The number one is acceleration, then there is another one, the second one is uniform motion, the third one is decelerating motion. So okay guys, I will give you the shortcut method to solve this question, okay guys. So always remember this approach whenever you face these type of problems. Is it okay guys? So now we'll try to solve this type of problems. Always remember the approach is graphical method, okay, and always try to make the VT curve, guys, okay. Always tries to make the VT curve, guys, okay. So in this situation, this is the uniform acceleration motion, and this portion is the uniform motion. Here the acceleration already given, that is omega, which is equals to 5 meter per second square. Is it okay guys? Here the acceleration will be zero because uniform motion, and the final the particle will be in decelerating mode, okay. So what is showing what question is saying, the omega here is deceleration same, that is 5 meter per second, okay. So guys, whenever you see these type of problems, so this is the, we know this is the VT curve, and the slope of VT curve gives acceleration. Okay guys, slope of VT curve, that will be acceleration. Is it okay guys? So here the acceleration is the magnitude of acceleration and deceleration is 5. That's why the slope means theta. The angle, the slope will be same. Here theta will be same. Okay, so remember this guys. Okay, suppose this point and this point. Suppose that the journey start from O. This point is A, and this point is B, this point is C, and this is D and E. So guys, this triangle, that is first and that is second, this triangle will be similar triangle, okay. This will be similar triangle, or we can say the area of, or we can say the area of triangle first and second will be same, because this angle is theta, this is 90 degrees, so these two angles are same, so that's why third angle will also be same. Is it okay guys? So now we will try to solve in this approach, or this is the, suppose that, sorry, this is the area third, this is the area second, so the area first and second is equals, okay. The area triangle, area first and area second will be equal, okay. So we know we have used these two approaches. The first is slope of VT curve will be acceleration, and the area under VT curve, that will be distance. Area under VT curve, that will be, okay, that will be distance, or we can say displacement. Okay guys, we can say displacement. Is it okay guys? So now what we have to do to solve these problems, we use these two approaches. So look at this question. A car starts moving rectilinearly means in this way. Acceleration 5 meter per second square, initial velocity is 0. Here we can say this is the initial velocity, that is equals to 0. Then uniformly, and then finally this is the uniform sector. AB portion is uniform and BC is decelerating portion. At same rate, omega comes to stop. The total time of motion is equals to tau, that is 25 seconds. So look at this guys, the total time from A to journey C, that time, that is equals to 2, and that is equals to 25 seconds. So first of all guys, we will try to solve these problems into variable, and at last we will put all these values, okay guys. So assume that I am the time taken from here O to A, I am assuming this time is delta t. Sorry, not this time delta t, this I am assuming the uniform portion, the time taken from A to B, that time is equals to delta t, okay guys. We know this portion and this portion equal time, okay. The particle will take same time from O to A and from B to C, okay. And the what is the value of these? this value here, this portion up to this portion, that is tau, or this is delta t. So this portion plus this portion, okay, that will be tau minus delta t. Okay, so we can write down this will be half tau minus delta t divided by 2. So the time taken from O to A, that will be tau minus delta t by 2. And here similarly from B to C, the time taken tau minus delta t by 2. Okay, here. Uh, okay, we write this another where the area A1 and the area A third will be equal because of geometrical properties. Is it okay, guys, till now? So now what is asking the total time of motion, already given the average velocity is given to how long does the car move uniformly. Okay, so we have to find out the distance AB. So first of all, to find out the distance, we should know we will find first of all time delta t. And how we will solve this? Okay guys, first of all we know the average velocity. Okay, this is the solution. We know the average velocity, that is equals to total displacement upon total distance or displacement upon total time. Is it okay guys? Here displacement is more appropriate word, but when displacement and distance is equal, we can use both of them. Okay, each of them. So now the total displacement will be area under VT curve. Okay, so the area and the total time, that is tau, or this is tau, or see guys, I am writing down this is the average velocity into the total time. Okay, what I am doing, I am cross multiplying this total time, and we know the total time, that is tau. Now the total distance or displacement, that will be area under VT curve. Okay, so the area A1, the area of first block, the area second, and the area of third geometry. Okay, we know the area first and third, that is equals to, that is area of triangle. Okay, or we can find out the velocity of this point. Okay guys, how? This is the initial velocity is 0, so at point velocity at point A, that is equals to initial velocity, that is 0, and the acceleration will be omega. Is it okay guys? And the time taking from O to A, that will be tau minus delta t by 2. Is it okay guys? So this is the value of point A, and the same here velocity is same. So here the velocity B is also same. That will be omega tau minus delta t by 2. Okay guys, so we know the value of this point. Okay, and this is the velocity max. This is the also maximum velocity. Okay, this is the maximum velocity, or we know the velocity, maximum velocity, that is omega t minus delta t by 2. Is it okay guys? Now we have to find out the area of this triangle. Okay, the area of triangle, that is equals to 2 into half. Okay, what I'm writing down, this area is equal, so I am multiplying this 2, and the area of single triangle, that is half into height, that will be maximum velocity, that is omega tau minus delta t by 2. This is the maximum velocity, this is the height, and this is the base, that is equals to tau minus delta t by 2. Is it okay guys? And the area of this rectangular, that will be height, that is Vmax, and delta t. Okay guys, so I am writing down this here, that is height Vmax, again height is Vmax, that is omega tau minus delta t divided by 2, and the time and the width is delta t. Up to here, is it okay guys? Is it okay? No problem. Now you can see here 2 is 2 cancel out. Okay guys, now guys, what I will do, I will take common from this expression. Okay, in this expression I am taking common omega tau minus delta t divided by 2, or inside bracket that will comes out to be tau minus delta t divided by 2 plus delta t. Is it okay guys? Up to here everything is clear. Now look at this expression, when we solve this expression, or here in left hand side there is average velocity into total time, that is tau. So we further we solve this. Okay, so this 2 will come here when you take LCM, and this will comes out to be tau plus delta t divided by 2. Here clearly you can see, guys, here clearly you can see that is a minus b or a plus b. So from mathematical algebraic expression we can write down this tau square minus delta t square. So further you can see, guys, average velocity into time, that is equals to omega. What I am doing, this two that will comes out to be 4. Okay, on this expression will be tau square minus delta t square. Is it okay, guys? Here a square minus b square. Now what we have to do, we have to find out the value of delta t. Now what I am doing, this 4 will come here. See, guys, look at this here. This delta t square, that will be equals to 4. Okay, the average velocity into tau upon omega. Okay, guys, and sorry, guys, here delta t square, here tau square. Okay, minus, or we can say, sorry, once again, here we can say delta t square, that is equals to uh, tau square. Okay, tau square minus 4 average velocity into total time upon omega acceleration. So look at this, guys. Now delta t, that will equals to under root tau square minus 4 average velocity into total time upon omega. When we put values here, we know, first of all, we will convert the average velocity, that is equals to 72 kilometer per hour. Okay, we will convert into meter per second by multiplying 5 by 18 factor. Okay, this will comes out to 4 times, that is 20 meter per second. Okay, so all values will be in mks unit. Okay, so tau, we know the value of tau, that is 25. Is it okay, guys? Here 4, the average velocity is 20, and the again time is 25, and we know the omega, that is acceleration, that is 5. When you solve this, okay, guys, or what I am taking 25 common. Okay, so in bracket inside, that will be 25 minus 16. Okay, when you further solve it, this will be 25 into 9. Okay, and this will be 5 into 3. So this is the delta t. Okay, that is 15 second. Okay, so remember this, guys, the particle will take time 15 seconds from A to B, or in uniform motion the time is taken 15 seconds. So the distance, how long, that will be the distance AB will be the maximum velocity into time, and time will be, that is delta t. Okay, or we can say the area of this rectangular. Vmax, we know the omega we know, that is value 5, and the total time, that is 25 minus delta t, that is 15 divided by 2 into again delta t, that will be 15. When you further solve this, this will be 5, and then this will be 10 by 2, this will be 15. Okay, this is again 5, this will be 25 into 15. Is it okay, guys? This will become, this comes out to be 375 meter. Okay, so again, this is the beautiful problem. Okay, guys, so remember to solve these type of problem, always help the VT curve. Okay, guys, thank you so much.